Albert Einstein was one of the greatest minds to ever walk this earth. But how did he earn the status of a world-renowned genius? Many people are familiar with the famous anecdote of Sir Isaac Newton's discovery of gravity, where he observed an apple falling from an apple tree. Newton discovered the presence of gravity but could not figure out what the cause of gravity was. Action at a distance is how Newton described gravity. It wasn't until 200 years later another great mind came along to improve Newton's discoveries. After 10 years of thinking, Einstein had finally come to a discovery that would drastically alter mankind's understanding of the universe forever: the theory of relativity. Relativity brought an understanding of the origin of gravity as well as its effect on space around us. Think of the space around you as being like a fabric or a sheet. Imagine placing a heavy ball on the stretched-out sheet. It creates a dent or a curve in the sheet. According to Einstein, this is what mass does to the third dimension of space. Massive objects like planets and stars warp or bend the fabric of space around them drastically. Instead of thinking of gravity as a force pulling objects towards each other, Einstein proposed that gravity is not just a force, but the result of objects following the curved paths created by warped space-time around massive objects. However, if we can't see space, how would Einstein's suggestions get proven? Well, if what Einstein believed was right, that gravity bends the fabric of space-time, then gravity should also be able to bend light, as light travels through space. In 1919, a group of British scientists developed an experiment to test this new theory of relativity. The Eddington experiment would soon be the engine that would make the name Einstein a household name. During this experiment, they set out to observe this gravitational effect of the bending of space, which represented the bending of light by extension. These scientists were experts at measuring the positions of stars in the sky. However, some stars are not visible to Earth at certain times of the year because the sun is too bright and would cause light pollution. This is why these experimental scientists prepared for a total solar eclipse. Once the moon covered the light of the sun in totality, they would have the opportunity to measure the position of distant stars. The sun is the largest gravitational field closest to Earth. If Einstein's theories were correct, when the light from distant stars passed through the sun's gravitational field, it would have bent around our parent star and appeared in a different position in the sky. And of course he was right. The scientists compared images taken to photos of the same stars a few months prior when the sun wasn't in the field of view, and the stars had moved positions in the sky just as Einstein had predicted. This groundbreaking observation provided strong evidence for the theory of relativity and catapulted Einstein to fame as he instantly became one of the most famous celebrities in the science world, winning him a Nobel Prize in 1922. The Eddington experiment proved his ideas were not just theoretical but had real-world implications. Einstein made many discoveries that significantly affected modern science, which led to him being known as one of the greatest minds to ever live. His famous equation, E=mc², revealed the relationship between energy and mass, introducing to mankind the phenomena of how small amounts of mass can be converted into huge amounts of energy. This discovery laid the foundation for mankind's understanding of nuclear physics and how the sun and other stars produce their energy, unlocking new possibilities for science and technology. Einstein's creativity and imagination allowed him to see the world in new ways than anyone had ever before. He was not an accomplished academic before he discovered relativity. He was merely a devoted thinker, a genius. Imagination is more important than knowledge, he claimed. His ideas inspired generations after him to think critically, question assumptions, and explore the wonders of the universe.